Hi guys, so this is the following day, and forum user Jula has pointed out that I should check the frequency when I connect the device, the transmitter, to the ground, and make sure that it's still the same, and I can confirm it's still the same. Also, another user posted on YouTube to measure the resistance between rod to rod. So I measured the DC resistance, and it came up to pretty well bang on 2K. It was actually 1.95 kilo ohm. So that's also, I've added that information to the forum topic. Thanks for that suggestion. And right now the circuit is back connected with the single wire all the way across over there. And you can see the connection there. So I'll just start the circuit. We're going to look at the scope shot. So there it is connected, and that is the current it's using, voltage times current. And if we look over there, the bulb is lit just the same as it was in the previous video. And that is the scope shot there. Gotta get rid of the glare there. Okay. So that is just the current probe being used, so I have isolation. I don't want to hook the scope up voltage probe to that very high voltage. So you can see there it's 1.1 megahertz, and if we bring it to a time division of 250 nanoseconds, we basically are fitting about 3 waveforms there. So that'd be another way to confirm it once we connect it to the ground rods. So there's our current, still the same. So we're going to stop the circuit now. Now the other thing I have to do is just slightly bend this antenna so that I have the same same amount of current draw, so that we can compare the test. Same. That's the antenna that does the auto tuning. I'm just bringing it closer to the circuit. If not, it'll just use 1 amp. I want it to go and use up to 1.4 amps. So now I have connected it to the ground. This probe is just laying on top of this wire here, just so that it's not on the ground itself. And now we'll connect this to the other ground rod. So we're both on each ground rod. Hopefully that bend of the antenna will be enough to so the circuit takes about the same amount of current. So we connect up the circuit. Okay, it's about 1.6. I'll just pull it away a little bit. There we go, 1.4. So the same amount of current, and at the voltage. And if we look at our waveform, there it is. Let me just see if I can adjust the trigger. And so we have 3 peaks there, and there is the pretty well exact megahertz. So the circuit is keeping the auto tuning at the same resonant state, and you can see that the amplitude is high and everything, and definitely comparable results. Just the trigger gets a little hairy there. Let me see if I can adjust it a little lower. Yeah, there's a little bit of modulation happening in it, so it's not the you can see that. But anyways, yeah, for sure that the frequency is pretty much the same, and there is the current, pretty much the same. And if we look, the only difference is we can't transfer the power through that 2 kilo ohm resistance through the ground. So there you go, light is not lit. So that's the only difference. Ground is a lousy transmitter, basically. These grounding rods in the soil here, which is mostly sand. Alright, so that completes this video.